let us come proper to calibration. I will fix this in a position that you can see. So we want to come proper to calibration. Good. I believe this is clear. No, it's not very clear. Okay, so when you want to calibrate, you add couplant to your steel. This is couplant. You add the couplant there to your material. That is our V2 block, and then you put your probe, set your probe on it. Once that is done, then calibration. This is our specimen we want to know. We don't know the thickness of this. This is an unknown thickness. So we use a known thickness to find the thickness for an unknown material. So let us go now to this other part. So I want to start the calibration for this. Good. I want to start calibration for this. The thickness of that V1 block is 20 mm. So let's come to base menu. This is base menu. Thickness for it is 20 mm. So we are going to set our range to times 4 the thickness of the known V2 block. So 4 times 12, 4 times 20 is 80. So our range is going to be 80. So I'm going to set our range to 80 mm. This is 80 mm. So whatever you are using, just multiply it by 4. That gives you the range for that particular material. So the next thing we will do, this velocity, longitudinal velocity of sound. We're going to set the longitudinal velocity of sound in carbon steel. So here, or in steel, we'll set it here. We'll click on it. It is supposed to be 5920. So we adjust it to 5920. 5920. This is for longitudinal velocity of sound in steel. 5920. This our delay. Come to delay. Delay is simply telling us where this initial backward echo would be. So our delay, normally just like your normal graph, you set, so we set this at 0.0. So starting from the origin. Now P delay is the last place we come to. So we'll go to the next sub menu. Next sub menu, damping, we set it at I, power I, dual, this is for the probe type we're using. So put dual on. In some other machine, you will see in this place of dual, you will see single. Once I rotate here, you see single in the other machine, like the Avenger 2 and also the Sonatest, you will see single. So here we have dual and then off. When you off dual, it means you are using single probe, a single cord probe. This is the reason we are putting dual on, because of these 2 wire, these 2 cord. That's why we are putting dual on, because of these 2 cord. If we were using only this angle probe, we would have used dual off here. So on dual on. So dual is on. Now PROF mode is I at the highest, which is 10. Now we go to the next. Next is reject 00. So everything here is okay. So the next place we want to go is the gate. This is the gate. So our gate, we on our front gate. You on the gate 1, while the gate 2, we are going to off the gate 2 because we are not needing information from the gate 2. We are doing thickness measurement. So let us go to gate 2. Now this is, before we go to gate 2, this is gate width. It is here you adjust your gate width. This is the gate now. This red line is the gate we have chosen. Watch, I want to adjust the gate width. Can you see? It's increased. Let me reduce it. Now I have reduced it. Can you see? It's increasing now as I increase. I reduce. So the essence of reducing it is, if in case you want to read a particular echo, you reduce it to touching only that echo. You reduce the size to touching only the echo. Now I want to move it to this place, to touching this echo. I'll come to this point, start. I'll come to start, click on start. Now I'll move it. Now since I've moved this to this place, the next thing is to make it touch. I'll come to threshold. come to threshold, bring it down. Now it's touching that particular echo. That's when you want to know the characteristic of any echo, an individual echo. That's when. But for this, since we are doing a full like thickness test, we're going to extend it to the width of the screen. So I'll go to width, cover, it should span through 100, or it's 80. Now come to start. It should start from 5. Now the reason we make it start from 5 is to circumvent initial echo, which might be as a result of initial vibration from the piezoelectric material inside of the probe. So we don't put it at the edge. We shift, give a little gap on the edge. This is where our reading starts from. These are the major echo we need to know their information about. Now come to threshold. I use normally either IS, or you put it at 20. Threshold at 20, no issues. But the essence of this is it reads the echo with the IS peak. That is what will be read. Echo with the IS peak. That is what will be read. So let us go to the next menu. Gate B. Look at gate B. This gate B, which is this green line you see here. We don't need it, so we'll put it off. Gate B, turn gate B off. So we have turned it off. We don't need it, so we have only one gate here. So we get information from only the front gate. Any other thing we need here? Since we have turned gate B off, all this other information or data will be turned off. Now go to the next phase. Preview. We don't need to preview nothing here. We don't need to preview nothing. Come to car. Good. Everything here. At 0.00. Everything here is okay. Start. Everything here is okay. DAC. We don't need DAC. And we deal with DAC when DAC simply means distance, data, amplitude curve. We don't need it for now. Now we go to the next one. Trig 0 degree probe. That is what we make use of here. So you can see it's already set to 0 degree probe here. Every other thing is okay. The thickness of the material, like this material we are using now, the thickness is 0. The thickness of this material is 20 mm. The thickness of V2 block is 20 mm. So you set it to 20 mm here. So 20 mm here. So we don't need to set any other thing here. We go to this one is to save your work. And so if you want to learn how to save, you can send a message there for me to know that you need to know how to save. I will know how to take care of that. So we are done with everything. We are done with the calibration of all this whole thing. Any other thing here? Nothing here. Okay, coming to this place, flank. We'll put it at peak. So we get information from the peak, not from the flank. The base here is called the flank, while the top here is called the peak. So information at the peak is what we need. So that gives us at the peak. So we are done with the setting. What we'll now do is to go and couple, is to return to the first menu, which is return to the base menu, and then we are coming to P delay now, where we'll do our final adjustment for this place to become 20 mm. Once this place becomes 20 mm, then we can go ahead to test any specimen of carbon steel material. So let us adjust this to 20 mm. We'll adjust it on our P delay. P delay, you tune the P delay until it is 20 mm. This thing looks like it's growing. Okay, tune it. Good. Now we're looking for 20 mm, 20 mm. So this is where the main calibration really is now. This is 20.1 something, 20.05, 20.04, 20.02. I think 20 is about here. So this is 20 mm. We are done with the calibration. So this is 20 mm. We are done with the calibration. You can see it's 20 mm there. So from here we can go ahead to test the unknown thickness, the specimen with the unknown thickness, which is this one. Can you see? You test couple on this one. What it reads here is what? 10.16, which is 10. But you are not testing only one place, you move it to different points of it. So we have checked here, we check here, now we check another direction, another point here. It is still giving us here 10.45. We still check another direction again, check another point again. What it gives us here is 10 point. The same way you check everywhere, it is giving us 10 point something. So approximately this material, the thickness of this material is between 10 point. You just copy this value, you see that is the thickness, the true thickness of this material. Thank you. Now, I will do another video for lamination test. So it's a continuation of this video. The timing here is just too exorbitant. Let's go to the next video.